Well, hello everybody, it's Wrangler back again with another Amiga video, and this time I'm returning to the AA3000 Plus project that I've been working on and done a few videos on previously. So in previous times I looked at the motherboard itself compared to the original A3000 motherboard. I looked at upgrading the firmware on the daughter board to support PCI DMA, and in the latest video I looked at the cable for the inbuilt monitor switcher, but all of that left one thing remaining. And you might remember from the first video that in order to have a case for that motherboard I had to take out my original A3000 motherboard out of its case and use that for it, and really that's sacrilege. You shouldn't really disturb a beautiful A3000 like that, an original one. So I've been on the hunt for a spare case, and at last I found one, and that's what you can see in front of you right now. So thanks very much to Matt3K on AmiBay. He had a spare one. Cheers, Matt. He had a spare one at which I bought off him, and that's what you can see here. But you know, in general, in very good condition. A couple of little scuffs on the surface, but nothing really to worry about there. But in great condition. But there's still some things that need doing. So let's just walk through those. We'll come back to the case surface a little bit later on, but you can see the very classic screws from the A3000 are missing. I don't think I'll ever be able to replace those, but if any of you know where to get some of those white coloured, beige coloured screws with the kind of insert in them, let me know in the comments box. But that's not the end of the world, right? Any screws will fit that. But let's just have a look inside the case. Generally in really good condition, so very, very pleased with that. But what have we got inside? Well, there are a few things missing. So we've got bays for the floppies and the hard disks. That's great to have the original mountings for those, but one thing that's missing is the power supply, so I'm going to have to do something about that. The other thing that often gets damaged on A3000s is the LED little PCB here. That's missing, so I'm going to have to do something about that. There's no floppy disk either, so there's some jobs to do on here. The other thing, just to show you while we're on it, is what about the inside of the case? Well, what is there is the original push rod for the power switch, so that does work, and maybe somehow I can connect up the power switch to the original assembly there to get that working. So how do we take this forwards? Well, one thing I have got as a spare already is an A2000 floppy disk drive. So at least in principle I could take the front off there, put it in the case, but what will be wrong is the button for the floppy drive. The A3000 has a wider button. So more on that later, see if we can get the floppy drive working. I guess the other thing, while we're talking about floppies, that's missing is I've only got the one floppy drive, so normally there would be a cover here to go over the second floppy port, which is missing. I've never seen one of those for sale. I mean, what I don't know though is whether anyone has one that's 3D printed or could 3D print one. So again, if you know about that, let me know in the comments box. Be really interested to try and get that sorted out. The other thing, in terms of trying to make this more complete, is a mouse. And I do happen to have a non-functioning original pregnant mouse from the A3000. The red tape here is just my little way of marking which mice and things don't work properly. And the problem with this mouse is it moves vertically, but it doesn't move horizontally. So again, I'm hoping that I can fix that up, use this mouse, the AA3000 Plus. So Lots to do: power supply, floppy drive, LED, PCB, mouse. Lots to do on this to see if I can get it all working a bit better. I might fail, by the way, who knows, and it might take a few videos to work through these things. So let's just see how we get on. So let's take a look at the power supply problem, because really you're not going to get very far without a power supply. I haven't been able to find an original A3000 power supply anywhere, so I then started looking at modern alternatives. Now, part of the issue is that this is by today's standards, a very unusual area, size, shape for mounting a power supply unit. But I have found this, and this is a Flex ATX power supply, modern one, which has power ratings that are the same as or better than the original power supply, so should be able to provide all the power that I need, and it does fit quite comfortably in the space left by the A3000 power supply. So let's just turn that around and see what that looks like from the back. So normally here is where there would be quite a large fan for the A3000 power supply, but actually the back of this replacement fits in that gap quite neatly, and means that kind of fitting it isn't going to be quite so difficult as I thought it might be. Because one thing I do not want to do is make any changes to this original case. I don't want to start cutting bits out or drilling holes or things like that, because, you know, suppose one day an original power supply is available, it'd be great to retrofit that back to here, take out the modern one, put the original back in. So I don't want to mess around with the original case, so everything has to fit in and around that. So really, therefore, there are two things that need sorting out with this power supply. One is to fit it, fix it to the case, because I don't want it sliding about. So I think that's going to be a bit of metal work to try and attach some of these fixing points here via a piece of plate metal perhaps, and onto some of the existing holes in the A3000 chassis. I'm not a metal worker, by the way, so that's going to be a bit of a challenge to fix that up. Equally difficult to see, but there is a fixing hole down here in the A3000, and that would be for the original PSU. You can see my replacement is slightly longer, but again, that's a potential fixing point for something, some bracket that I'll have to make to attach the front of the power supply to keep it nice and secure. So that's part one, is, if you like, the mechanical parts of it. The other part of it is the electrical requirements of the power supply itself. Now, what I mean there is that this power supply has certain load requirements on some of the different voltage output rails, and in particular, if there isn't a certain load on the 3.3 volt output and another load on the 12 volt output, it could end up damaging the power supply, and I don't want that. So I'm going to have to rig up, using some resistors, a dummy load on each of those voltage rails, so that even when nothing else plugged in, it'll be safe to turn on the power supply. So quite a lot to do there. I mean, obviously the other thing, I guess, is this is an ATX connector. That won't be able to plug straight into the motherboard, but there's some well developed and easily available adapters for that, so that's not a problem. I've got one of those already, as it happens. So mechanical things to do, electrical things to do. Hopefully we can get all that working, and then that will at least enable the motherboard to be turned on, even if the other stuff, floppy, LED lights, mouse, all the rest of it, isn't working. Lots to do. Right, as I say, there are two things that have been bothering me about the power supply unit but one is electrical, making sure that the power supply is loaded properly to make sure it doesn't overload and make sure it functions properly. The other one is actually mounting the power supply unit actually in the case, because it's going to be no good flopping around like this. So clearly there are no off-the-shelf solutions to that. It means creating something, some sort of mod. So what have I done? Well, as I pointed out before, I think there are two mounting points that we can use. One is a screw bolt hole here, which is normally for the A3000's own power supply unit, and the second one at the back. So I think we need to use both of those. We've got 2 points of attachment. But what to do? Well, let's just have a closer look at the back side first. So what I did was to draw a template in paper, just to get the dimensions right, of a mounting bracket, you might call it, or plate, that can fit at the back here, cover up where the old power supply connector would have been, the mains coming in there, but it also covers up this space at the top that we'll otherwise get, and we'll end up with quite a nice sort of enclosed space here. One hole here to attach the plate to the case, second hole here to attach the plate to the power supply unit, and I suppose if I wanted to I could use the third one over here on one of these fan holes to attach to if I really wanted to, but that looks like quite a good fit if I can get that to work. It will still leave this empty space at the bottom. I suppose if I really wanted to I could fill that in as well, but there aren't any obvious mounting points here on either side to actually attach that plate to, and actually a bit of extra ventilation, perhaps not such a bad thing in an A3000 case, which is pretty cramped usually. So that's the first template. The second one, just turning around, and hopefully you'll be able to see this, is, as I say, on the other side, slightly different shape here. I thought of different ways of doing this, but in the end what I really need is a sort of angular piece, and turning that around, if that connects down the side of the power supply unit, hopefully you can get your big hands out of the way, you can see that. It could connect down onto the case here and into the power supply there. That will hold it like that. So, two paper templates. I happen to have some sheet aluminium kicking around, so from the templates I made up these two brackets and drilled them out, and they are going to do the job of attaching the power supply unit to the case. Nothing very clever here or out of the ordinary, just sort of cutting and bending bits of metal. I suppose the one bit is getting this angular shape. How did I do that? I thought I had some angular aluminium already, but it turns out I didn't. I only had the flat plate. So in the end what I did was to attach an iron bar to this piece, clamp it to that, and then that gave me leverage to bend this piece upwards 90 degrees to get this nice corner edge on it here. What I was concerned about is getting some sort of floppy corner, jagged corner or something, but actually attaching a piece of iron bar to one side really helped with that, and actually it wasn't too difficult to bend it. So that worked out really pretty nicely. So all that remains now is to attach these things. So let's start at the back. So I've measured out the holes here, and it's just a case of screwing these things in. And of course I can't get to exactly where I want to because the camera's in the way, so hopefully this will work, and perhaps it might have been easier to do this with the power supply out of the case, but there we go. Never do anything the easy way. And I've got to do this left-handed. Right, so that's the first one in. This ended up being a 5mm bolt. The only one I could find is like massive, huge thing. If I can get hold of any shorter ones, I will replace this because it's a bit ridiculous having such a huge thing on such a tiny joint here, but anyway, it does the job for now. I'll just tighten that up. And you know, we're not looking for super strength here, we're just looking for enough to hold it firmly. So that's connected to that. There we go. And I think you can see the idea now. So this is closed up, that's closed up, looking pretty good. Already fairly firm, but we need the front bracket to really secure it. So let's give that a go. And see if I can do this. Left-handed. Doesn't want to go in. Right, here we go. There we are. That's better. And then the final one, which does take a little bit of jiggling around to get exactly right, because inevitably some of this is a little bit approximate. Whoops. And it doesn't help when you've got big fat fingers like I have. Right, that's in. Just a quick tighten. All right, so both brackets done up. That is now pretty rock solid in there. Really happy with that. That's not going anywhere. Nice and safely held in as well using the existing attaching points. Haven't had to drill any holes in the power supply unit itself. So delighted with the outcome of that. That's the mechanical side of things done. Now onto the electricals. So looking at the electrical side of things, there's one aspect that I keep on going on about, which is the loading of the power supply unit so it runs properly. Come back to that in a moment. The other side of it is simply connecting the thing up. So I've got one of these adapters that takes ATX in there and then out puts the power through the standard A3000 connector there, and then we've got these flying leads for the switch. Back to that in a minute, but you know, this once I've got the load set up okay, this should be a pretty simple task. Just connect those two together and straight down into the motherboard, so that's fine. The problem comes from the other end, which is the switch, because really, if possible, I would like to get this connected up to the original A3000 power supply switch, which sort of comes out here somewhere. So I'm going to have to think this through, and this is going to be the toughest bit of the modding, I suspect. Somehow, is it possible to build on my little bracket here, perhaps put in some sort of riser and support it up here? Remember, there's a push rod on the end of the A3000 switch. Can I somehow connect that up to the switch here? Don't know. I'm going to have to work on that one quite a bit, and maybe to begin with do without and just have it trailing just to check the thing works. Come back to that later on once I've done some more head scratching. But the next thing is the loading of the power supply. Let's think about that. But before I do that, really, I need to take this power supply out so I can work on it. Okay, so let's talk about the electrical aspects of the power supply first. So actually, in more detail, what power supply am I using? Well, this is an FSP 250-50 PLB. I think I said before, this is a Flex ATX power supply specification, standard of size. So that's something perhaps to think about if you ever want to put a modern power supply in your Amiga. These do seem to fit with a bit of modding. But what about the electrical aspects of this? Well, actually you can turn on the fact sheet, the data sheet for this power supply, and what it says is that it needs to have certain minimum loads. So what are they? Well, first of all, on 3.3 volts it needs 0.3 of an amp, 5 volts also 0.3 of an amp, 12 volts a full amp. nothing on the other lines particularly. Now 5-volt load shouldn't be a problem at all. The Amiga motherboard will draw that kind of power, so that's fine. 12 volts, well, if I'm running a conventional hard disk or something like that on the Amiga, then that should be fine too, because that will make sure that there's about an amp, I would have thought, being drawn from 12 volts. The trouble is, what if I'm not using a conventional hard disk? What if I move over to an SD card or something like that? It's probably not going to draw anything on 12 volt line. So I think ultimately I will need to put some sort of dummy load on 12 volts, but the one that really needs looking at is 3.3 volts, because that's not used anywhere at all on the on any Amiga system. So I need to load that up. Now 3.3 volts and 0.3 of an amp. It's the old formula. The resistance I need is the voltage divided by the current. So 3.3 divided by 3, where you get to about 10 ohms. So what I've got here are some 10 ohm resistors. Now what about the power draw? Well, the power is the current squared times the resistance, and therefore you end up with just over a watt being consumed in terms of power. So 2 watt resistor ought to be fine for this load. So that's why these are 2 watt, just to be able to cope with the power that's going to go through them. So I need one of these first of all, and then start working out how to connect it up. So there's my resistor. Now, just looking at the various leads we've got coming out of this power supply, what have we got? Well, there are 3 what I would call Molex connectors, the big 4-pin ones coming out. They'll be quite useful for connecting up to hard drives and all the rest of it. There is also one of these floppy power connectors, so that's good. But if you look at the color coding of all the cables connected to those plugs, red is 5 volts, black is ground, and yellow is plus 12. There are no 3.3 volt connections to any of those, so they're not going to be any good. This is the ATX 12 volt power, which we won't be using at all, but as the name implies, it's only got 12 and 0 on it, so that's no good either. The only source of 3.3 volts is actually the ATX power connector itself, so I'm afraid I have to take the cable cutters to this, and I think what I'm going to do is just be really careful about which one I'm cutting, because you can see here this pin actually has got a double connection. It's got 3.3 volts going in and then a sense cable coming back out again, so I don't want to cut that. But what I can do is cut this one and use that. So let's just take the plunge and do that. I'm not going to cut it right at the end, just in case for some reason I need to come back to that. I can always cover it up with a bit of heat shrink or something. So that's that. That's going to be our 3.3 volt source. Just strip the end off that to get that ready for soldering. So where's my resistor gone? So I can connect my resistor into the power there, but I need a return ground for the other end. I mean, I could cut a ground cable on the ATX connector, but I don't really want to do that, because those grounds are probably each going to be used to go into the A3000 motherboard, and I don't want to overload the other ground cables. I much prefer to use the ground from one of these instead. Now I could cut this, but again, don't really want to do that unless I absolutely have to. So instead, what actually came with this power supply was a converter from Molex on one end to SATA on the other end. SATA without the 3.3 volts, unfortunately. I don't really need that for Amiga stuff. Amiga doesn't use the SATA power or any kind of SATA capable drives or anything like that. So I'm going to just use this. I'm going to therefore expect to connect that into one of the connectors here, and I can use the ground as the return path for my 3.3 volts. So that all seems sensible enough. So I'm just going to cut the end off that. I will also be able to use a black and a yellow, so that's 12 volts for my 12 volt load. I've got another similar resistor coming that will provide the load on 12 volts if I'm not using a conventional hard drive, for example. But that hasn't arrived in the post yet, and I don't know if you're finding the same thing during lockdown. Some things arrive really quickly by post, other things just seem to take forever, and it's never clear why that is the case. It's just random, so don't have that yet. So for testing purposes, I am going to use a conventional hard disk, and it's probably far too small to read on there, but plus 12 volt load is almost an amp anyway, and it's also got a plus 5 volt load, so that should be enough to load the power supply. When I've got 3 volts load with a dummy load on it, that should be enough to mean I can turn this power supply on and not do anything harmful to it. So let's just keep snipping, cut the end off this extension cable, and again might just leave a little bit spare just in case. It's amazing how many times you do these kinds of things and then realise you want to undo it all again. So we won't be using 5 volts. All we need is this earth. I might as well keep those two that are together for the 12 volt dummy load. And I suppose one thing I did do was to talk about the minimum loads that this power supply can take. I suppose the other interesting thing is what's the maximum load. So the important number here really is a 5 volt power line that could take 20 amps. Now that's actually more than the original A3000 power supply could deliver, so there's going to be plenty of beef in this setup. We shouldn't need to worry about that too much. So I'm going to cut these really quite short because we don't want extra resistor legs kicking around. And the other thing I need to remember to do before I go too far is to get some heat shrink ready as well. So let's just have a bit of that. Right, now I am not sure how much of this is going to be visible on the video because it's really difficult to solder at arm's length and keep it all on video. But let's see what we can do. Right, and this is probably where I'm going to end up burning my fingers. Okay, happy with that. So as I say, ultimately I want to do the equivalent thing on the 12 volt rail, but for now we will just pass on that. Right, let's get this sorted out, the other end. Oh yeah, more heat shrink, let's not forget that. Got to tell you, while I'm doing this, I have the utmost respect for people like Gadget UK and Jan Beta, who constantly soldering while on video camera. I don't know how you guys do it. You must have very long arms or very good eyesight, or both, better than mine, to be able to do it. And very steady hands, which again I don't possess, so that's 0 out of 3 for me, but you guys seem to be able to do it all the time. Let's push that out of the way. And the heat shrink. I suppose there's a fourth quality that those guys have got as well, and that is that they can solder really, really well, whereas mine is pretty sort of primary school standard. I can just about wire up a resistor like that, but I wouldn't trust myself with anything more complicated than that, I've got to tell you. Right. That is that. What we should be able to do now is hook this all up, turn it on and see if the whole thing explodes or not. So let me get all the wiring done and I'll be back in a minute and we'll fire it up. Alright, I'm back with the various bits and pieces now, so let's start wiring this up. It all looks a bit of a mess right now, but let's just step through it. I realise that actually I need the converter back for the switch to be able to turn it on and off. Let's just make sure that's off first of all, so that's good. I've got my dummy load on 3 volts there, which I need to connect, otherwise that's not going to do anything. So let's just plug that in. There we go, so that's now a circuit. I've got my mains coming in there. Connect that in a minute, and let's just make sure the hard drive is plugged in as well. Alright, so that's all of that. I guess what I just want to think through before I actually fire this up is, what do I expect to happen? I think it's always a good idea to have that in mind when you start anything up. So what should happen is the fan ought to come on the power supply. So actually, maybe if I turn that around, we might just get some sort of visual indication that something's happening with that firing up. And also we ought to hear the hard disk start up. Now that might be a bit quiet to be recorded on the video, don't know, but let's just see. If it goes bang or smoke comes out, then that it didn't work. So let's just give it a go. Well, so far so good, so the power is on, and let's just give it a click. And I don't know if you can hear that, but the fan is on, and I can just hear the hard disk clicking. So that's a good sign. Now is my resistor. Just faintly warm, so that is dropping a voltage across it, and I can feel that is actually spinning. It's just, you know, hard disks, you could just sort of feel them humming a little bit as the disk inside spins round. So that actually seems to be working very, very nicely. As I say, just needs a bit of tidying up with the 12 volts just to get that loaded up, so I don't need to keep this hard disk plugged in to run the power supply, but it seems to be working pretty well. This isn't getting warm at all, so that's good. Alright, turn it off. Fine, it's shut down. Good, so that seems to be working perfectly. Very pleased with that. On to the next thing. So let's look at this mouse problem a little bit further. I've got my broken A3000 pregnant mouse here that's plugged into the A4000 that I'm using for testing. That's what you can see on the screen here. But I've plugged the non-working mouse into the joystick port, or the second mouse port, just for testing purposes. In the main mouse port I've got the regular A4000 mouse here, so I can actually use the machine properly. So this is fully working, and I'll just show you the kind of problems that I'm finding through a little utility that I came across. Alright, so let's just centralize that a little bit further and turn off some of these other windows. But here we go. So port 0, the mouse port, this is me using the regular mouse, and you can see the directions are showing up nice and clearly. So let's just be a bit more precise about this. Moving up, regular ticks on the up arrow, moving down, regular ticks on the down arrow, left and right. So that's kind of what you'd expect to see. You've also got some counters here counting up and down as I move in the two directions. So let's just go up. Let's keep an eye on this white counter. So the last byte there, 7.6 at the moment, counts up as I move to the right, counts down as I move to the left, and then the byte before that, 9F, counts down as I go up and up as I go down the screen. So that's kind of giving me my mouse coordinates, so that's working really nice. Okay, so that's port 0, that's the mouse that's working fine. Let's look at port 1, which is where the pregnant mouse is. I mean, first of all, the interesting thing is that it's showing that port 1 is a joystick and controller type is listed as a joystick. I'm not quite sure what tests this program does to decide whether it's a mouse or a joystick that's attached, but it thinks it's a joystick. And by the way, if I swap the connections round, it still thinks it's a joystick. So it's not the fact that it's plugged into port 1. The second thing you can see is port 1 DAT there on the left hand side. Let me just perhaps zoom in a little bit so you can see that a bit better. Is actually fluctuating even though the mouse isn't moving at all. So that's weirdness straight away. But now let's just try and use this mouse. So the first thing I'm going to do is just go upwards, and you can see it's got some sort of signal on the up arrow there, but also very weirdly the left as well. So that's just not what should happen. This is the mouse that works when I do the same, just going up, and I can't quite go up in a straight line. There we go. It's only the up arrow that's ticking, whereas with the broken mouse it's up and left, which is weird. Now let's go down, and I still get up and left. So why is that doing that? That's just really odd. Whereas down on the working mouse, it's just the down arrow that ticks away. So even though the pregnant mouse will move up and down on the screen, still the signalling isn't right for up and down. Now left and right, left, just nothing, right, again, nothing. So this mouse, the pregnant mouse, is really pretty sick. That's interesting. So the controller type was switched to mouse there. I don't know if you can see. I don't know why it has done that. And now back to joystick. So something is really pretty sick. And my theory is that it's the comparator chip inside the mouse. So that's the next step, is to rip that out, try not to destroy the thing in the process, see if through that I can diagnose a little bit better what's going on. But it's a pretty sick thing, not a sort of simple case of perhaps the one of the slotted discs being interfered with or not turning or something like that. That would be another reason why it wouldn't move left and right, but would move vertically as a mouse. Nothing simple and mechanical like that. It does seem to be sort of electronic problem somewhere. But let me just dig into this a little bit further, see if we can work out what's going on. So let's just have a look at the inside of the mouse just to try and figure out what's going on in here. So just lift off the lid very carefully. By the way, I've undone all the screws already. Just pull out the little PCB there. And you can see it's a pretty simple design. You've just got the two wheels here that turn as the mouse moves. They break an infrared beam across here because they're little slots inside the tiny little wheels here. So that repeatedly breaks the beam. In fact, they're dual beams. And the order in which the beams break tell the mouse whether it's moving one way or the other way, and the same way left and right. And all of that goes through a single chip down here that simply compares the voltages that it's getting, either seeing a beam or not seeing a beam, against a reference voltage, and that creates a nice on-off kind of signal. Beam's on, beam is off, rather than a sort of variable voltage as the light changes through the little slots in the wheel here. So that chip does that conversion just to create a nice wave, sends it back through the cables, and actually it's the computer that does the rest of the analysis of working out which direction the mouse is moving in and the like. So far that is all pretty standard amongst all Amiga mice. But what changes a little bit for this mouse, the pregnant mouse, is what's underneath, and I don't know how easy that is to see there. Let me try and zoom right in, but there is an absolute forest of resistors and capacitors here. And when I have been around with a multimeter and try to work out what's going on here, it's very clear that the circuit layout for this mouse is very different from the one or two mouse schematics that are on the internet. There are many more resistors in the A3000 mouse here, and as far as I can work out from my very limited electronics knowledge, these are all about just biasing the voltages to get them exactly right, something that doesn't seem to be too much of a concern with kind of regular tank mouses and the like. Now, I've been around with a multimeter just sort of checking resistances, checking voltages when the thing is powered up, and I get a mess of results. It's just really difficult for me to work out what exactly is going on. But it just strikes me that kind of when you step back a bit and think, well, what could have gone wrong? It seems to me unlikely that any of these resistors will have gone bad. They all seem to be having the right kind of resistance in them, as far as I could tell. Same with the other passive components. Really, is it likely that they've gone wrong? Probably not. The one thing I should say that I have checked is that the photo transistors here and the photo diodes that do the little infrared beams on both things, both wheels here, are working, and they are sending out signals. Now there's a bit of a question as to whether they're sending out the signal at the right voltage level. That might be one problem. Perhaps one of them's gone weak over the years, and that means that the on and off signals both get interpreted as on by the comparator chip. That could be one possibility. But as far as I can tell, they seem to be functioning okay, which is leading me to wonder whether actually the culprit might be the comparator chip itself that could be fried internally, because, you know, if this mouse gets plugged in, hot swapped perhaps, or someone's fooled around with it in the past, what's the thing that's going to get fried? Well, it's that comparator chip. So my theory at the moment is actually let's replace that if I can, and see what that improvement makes. And perhaps actually, rather than doing all of that in one go, first thing to do is to remove the comparator chip, then measure the voltages again with the chip's not there, and possibly, I wonder, influencing the results I'm getting, the kind of weird readings. So do the voltage checks without the chip there to interfere, and then replace it with a new one. and hope that that is what fixes it. It certainly would eliminate one thing, and being able to measure the voltages without the chip in the way will help, I think, because if it's the other possibility that I can think of, which is perhaps the phototransistor aging over time and the bias, the range of voltages that it's picking up just sort of has drifted over the years, it'll be a lot easier to tell if that's the case, and then, you know, adjust for that via adjusting the reference voltage that it's using. So in other words, if the voltages from the phototransistor have drifted down over the years because it's aged, actually all I need to do is adjust the reference voltage down as well, and then the comparator will work, right? And it'll come back into full functionality. So I think the next step is remove this chip if I can. I mean, it's just really fiddly soldering, you can see right in here amongst all of these different components. It's going to be a right swine, so there is every possibility that I just ruin this on the way, but let's give it a go. Well, dig into it I did, and quite a lot of time later I think I have sorted out what the problem is. So I have got the pregnant mouse plugged in right now, controlling the arrow, and perhaps if I just zoom in a bit, we might be able to see that arrow a little bit better. And there we go, it is moving it around. Now the mouse is sort of undressed at the moment, so it's not in its proper shell, so that's why it's just sticking a little bit on the surface here. But let's go right, can I go right and left? There we go. So it is working here. So the ball is sticking slightly, so let's try it without the ball and just manually rotate the slotted wheel. So there we go. That is now working a lot better. So I guess the natural question is, well, what was wrong with it? Well, it turned out it wasn't the chip on the mouse. I did take that out, spent a lot of time with the multimeter checking out voltages, resistances, all this kind of stuff. Ended up replacing that chip anyway. None of that fixed anything. What the issue turned out to be was my number 2 candidate, which is that the phototransistor on the horizontal dimension of the mouse actually had sort of faded over time, so that the voltages that it was passing through and the resistance that it had kind of worsened over time, and so it really wasn't passing enough voltage to be picked up by the comparator chip. If you like, the voltage was always too low for the threshold for the comparator chip. It never got high enough to trigger it. So what I have done, and pretty tacky soldering here, I don't know if you can see that, is a couple of resistors on the back of the transistor, phototransistor there, which adjust the voltage levels and bring them into the level that actually can be picked up by the comparator. There we go, left and right. So I think actually I need to put this all back together and hope it still fits in the shell, but actually that looks like that could be a success. So I'm really pleased about that, because you know, these pregnant mouses aren't easy. Pregnant mice aren't that easy to come by. Well, I've made lots of progress now with the power supply unit and with the mouse, so that's great. But we've run out of time on this video, so join me next time when I'll be making some more progress with the AA3000 Plus and getting it closer back to full operation. See you for now.